Okay, so today we're going to talk about section 3 of chapter 3. I'm going to do things a little bit differently on this one. You're going to see here. I don't exactly care for the PowerPoint slide that's included, so I'm just going to sort of do this my own way. I'm going to give you the same stuff, but I just don't care for the way they talk about it. There's two things that matter here. Okay, we're going to be doing derivatives again. This time we're going to take it of products and quotients. Basically, that means if you're multiplying two things together or dividing two things, we want to find the derivative. So, for example, if I have a function that looks like this, so this is a classic case of two things are being multiplied together. This is the product. Okay, so I want to do this the old way first, and you'll see why we're going to have a shortcut in a second. If I FOIL this out, this is what I end up with. And notice I have not taken the derivative yet. I have just FOILed this out and trying to get that, this thing, not simplified, I guess, but just expanded out a little bit. So now I can take the derivative. And you see when I take the derivative, it just simply becomes a 6x minus 1, and I have the answer. Okay? But what's going to happen is, as these problems get larger, say you have more and more things multiplying together, or you have powers up here, it's going to take a while to expand them, and it's not always necessary, as you'll see with our next example here. So, depends on how you see things, and I want to try to be a little bit parallel to what the book is. Like I said, their notation's a little different, but I'll show you how it works here. What they're saying is, if you have a function, and they call it the first times the second function, okay, f of x times s of x, that stands for first and second. Just like we have over here, we have a first and we have a second, same kind of idea, okay? So the formula is, I'll give myself some more room over here. So the derivative turns out to be, you take the first function, leave it as it is, and you multiply by the derivative of the second. And then you're going to do the same thing where you take the second function and you multiply it by the derivative of the first. Okay, now it seems like it's more complicated, but it's not so bad. I'll show you the example right here. Same problem. We have this 3x minus 7. We've already found the derivative. As you see, it's in the box here on the left. But we had to FOIL it out. We had to do a lot of extra steps to get it ready to take the derivative, but now we're going to do it the same way here, okay, with this formula. Now keep in mind, this is the first function right here. This is the second function. In fact, I'm going to use a different color on this second one here. Let's use a green one. Okay, so if you think about this formula right here, okay, to find the derivative, I don't have to do anything. I get to jump right into it. I take the first function, I leave it as it is, no change. 3x minus 7. Notice it's the exact same function, but then we multiply by the derivative of the second. Well, the derivative of x plus 2 is just a 1. Okay, the derivative of this right here. Took that derivative. All right, and that's how I got this piece right here. All right, hopefully that is okay. Then you continue with that formula that I have circled here, which says you take the second function, keeping it as it was, and you multiply that by the derivative of the first. Well, the derivative of the first right here, that derivative is just a plain 3. So it's like two little derivatives is what we're doing. So again, I'm sorry, make sure we're clear. That was the f prime. That's what we're working out right now. Okay, we're finding f prime of x with the formula. So now I just kind of clean this up a little bit. I get a 3x minus 7 plus an 3x. Distribute that 3 over there. 3x plus 6. Now I end up with a 6x minus 1. And notice, same thing that we had over here. Okay, now, big picture, you look at this, some of you are going to say, well, the amount of steps over here was just about the same as over here. And I'm going to agree with that. That's about the same. But This problem on the right, we kind of kept it tame. We kept it under control. We never got any big powers. Everything stayed nice and small, whereas on this one over here, you have to expand it. And like I said, if these powers are big, right here and here, or if there's numbers up here as powers, this could get to be very large. This could take a long time. So the product rule lets you skip a lot of that and just go right to this here. So I'll show you more examples as I go here. Okay, so now we'll look at this one here. Let's say we have y equals 3x to the third minus 7x squared plus 5x times x squared plus 2x minus 5 again. Now, if I did it the old way, I would first have to expand all of this out. And if you're not sure, remember, when you FOIL, you're multiplying 2 terms times 2 terms, 2 parentheses multiplied each other. So when it's 2 terms times 2 terms, you get 4 terms, and then after you FOIL it, and then you put things together. Well, if I have 3 terms, multiplying by 3 terms over here, that's going to give me 9 terms. Okay, so when you FOIL this out, you have to take the 3x cubed and multiply to every one of these. You got to take the negative 7x squared and multiply to every one of these. You got to take the 5x, multiply to every one of these. That's why you end up with 9 terms. Okay, and that's where I was talking about, where it starts to get a little bit out of hand, and you're going to get powers all the way from 5 down to, a constant. You have all these terms, you're going to get 9 terms that will probably condense down to about 5 or 6 terms, and then you take the derivative. Okay, but with our new product rule, and that one I was talking about before, that is the product rule. You take that first parenthesis and you do nothing with it. Then you multiply the derivative of the second, well, that's a 2x plus 2. Then you take the second parenthesis, leave it as it is, and you multiply it by the derivative of the first. So that's going to be a 9x squared minus 14x plus 5. Okay? Now, the nice part is we have the derivative right here. This is it. It's the derivative. The only thing left is maybe we're going to do a little cleaning up. Now, notice some of you saying, well, we're still going to have to FOIL and multiply a bunch. And that is correct. But the powers are going to keep a little bit smaller. They're not going to be as ugly here when you're doing this thing. So clean this up a little bit. Remember how this works. The 3x cubed multiplies to each. The negative 7x squared multiplies to each. And then the 5x multiplies to each. And yeah, we're going to get a bunch of terms, but show you that it's going to be not as bad. So we get a 3x cubed multiplied by the 2x and times the 2, we get these terms. Then I distribute the negative 7x. We get a negative 14x cubed minus 14x squared. Then I distribute the 5x, I get a 10x squared plus a 10x. Then over here I'm going to FOIL a lot of stuff as well. So I'm going to draw kind of an imaginary line just so you're clear where we're getting all this from. And remember, x squared times everything. So that's a 9x4 minus a 14x third plus a 5x squared. Then a 2x times everything. We get an 18x cubed minus 28x squared plus 10x. And then last, the negative 5, we get a negative 45x squared. Sorry. Make sure I got everything right here. Got to check it as I'm going here. Minus 28, sorry, not 28. 14 times 5. So we're going to get a plus 70x. And lastly, a minus 25. Okay, so you're not going to be able to, excuse me, avoid all the multiplication, but at least we can kind of keep the numbers, the powers from getting too large. Okay, and like I said, you're going to learn some new rules, and we're going to combine it with this in a second. It's going to make life a lot easier when we're trying to simplify everything. So, kind of watch what I'm doing. I got all these terms up on the screen. All I want to do now is, I have the derivative, by the way. Again, this is the derivative. It's just a matter of me combining terms, combining similar terms. So I'll take the 6x fourth and the 9x fourth. That's going to give me a 15x fourth. Now I look for all the 3's. That's one, that's one. Let's do a different color here. So that's a power of 3, that's a power of 3, that's a power of 3, that's a power of 3. So I just put them all together in one step, add all those numbers up. So I get a negative 8 plus a 4, looks like I'm going to get a negative 4. Now I'm going to do the x squares. We get an x square here, another x square here, another one here, another one here, and another one here. Same thing. Add all 5 of those now, the coefficients. So we get a negative 4 plus 1 minus 27. Looks like it's minus 62. And I just keep chugging along here. X, X, and an X. Looks like I get a 90X. And lastly, my number, my only number I see up here, use that yellow, that's the minus 25. Okay, now that's your derivative. What's going to happen though is we're going to be doing more stuff with this. The main goal is we can get down to this line right here. We've at least got the derivative. Now, all this other stuff I did in these final steps, this is simplifying. Okay, it's important, especially here in the beginning, but as time goes on, you're not going to need to simplify it all the way. You're just going to be asked to solve or set it equal to 0 or to find a slope given a certain x. You know how we've been doing with the derivative. You get the derivative and then they say, well, what's the instantaneous rate of change when x equals 3? Then you plug in 3. Well, I could plug in 3 to this bottom line, or I could plug it into this one right here. Either way, I'm going to get the same answer. And if I know I'm plugging in a number, I'm going to go right up here. I don't need to clean it up. I'm just going to plug in numbers and start simplifying. What's important, though, like I said, is that first step gives you the derivative immediately. You don't have to do any preliminary work, any cleaning up, any of that stuff. Okay? So that's, like I said, that's what's going on here when we deal with these different formulas. We call it the product rule. I apologize. That's what it's all about. Okay? So let me clear up another one here. Let me give an example. Okay, so some things you're going to have to do. I'm going to take an example here out of our book. We have f of x equals 2x minus 9 all over x squared plus 6. Okay, in fact, you know what? They have this in the PowerPoint slide. Let me move the slide over just so you can see this. And you don't have to see me writing every step, but I'll just narrate and walk you through each of these steps here. Okay, so where is it? Here it is. Okay, so read this problem, kind of see what's going on here. We have a function, f of x equals parenthesis 2x minus 9 times x squared plus 6. They want you to find the equation of the line tangent to the graph at f of x at x equals 3. So again, remember, tangent line means I need to get a slope, and the slope of the tangent line comes from the derivative. So first step, let's find the derivative. All right, so we found the tangent line of f of x at 3 has a slope of 12. All right, now I'd like to see that a little better, so I'll kind of show you what I'm talking about here. They didn't work this all the way out, but find the derivative. Okay, in fact, let's go back one. Okay, right here, sorry, once again. Okay, going with our new rules here. We take the first piece, the first parenthesis, multiply it by the derivative of the second. Then you add the second piece, x squared plus 6, and you multiply that by the derivative of the first parenthesis, that's a 2. Okay, now you don't have to clean this up, but we can. I'm going to leave it there to show you the example. We didn't have to do all this other stuff. What we want to know is, because remember, this is the formula for the slope of the tangent line. Right here. Once you have a derivative, doesn't matter what form it's in. If you have a derivative, it's going to give you the slope of the tangent line if you plug in the x. Well, we have an x right here. So I'm going to plug in that 3 right here. Instead of simplifying it, I'm just going to go find f prime of 3. So I get a 6 minus a 9. I get a 6 here. I get a 9 plus 6 times 2. And then we just do a little bit of math here. We get negative 3 times 6 is negative 18. 15 plus, times 2, is 30. And that's how we get a 12. That means however this curve looks, at 3, we have a slope of 12. Okay, that's what we found. That's what the next line is. So they kind of glossed over that, but I wanted you to see that. So pause if you're not sure. All right, now this is how they get this. Okay, did I miss this? There it is, right there. Okay, so this is how we're getting that 12. I might have been a slide too far. So same thing I just did. Now we know at x equals 3, the tangent line to the function has a slope of 12. But remember the question, they want us to find the equation of the tangent line. So in order to find an equation, we have to know what's the slope and what's a point. Well, we had the slope of 12, and then remember, the tangent line is touching your graph at exactly one point at the x value they say. So instead of the derivative, now we're going to plug the 3 into the original function up here. Okay, so clarify the two things. When you plug in 3 to the derivative, you find the slope of the tangent line. When you plug in a 3 to the actual function, not a prime, you find the y value right there. Okay, so in this case they plug it in, you get a negative 45. So we have a slope of 12. We have a point of 3, negative 45. You use the point slope form right here, and plug in the negative 45. Plug in the 3. Plug in the 12. Clean it up, and then you get the equation y equals 12x minus 81. That's the equation of this tangent line right here. Okay, so I'm going to jump over to Desmos real quick just to give you an idea of what this thing is. Okay, so on this particular one here, I'm going to graph this function just to give you a visual of what we just found. Because a lot of people, they can find the derivative, they have no idea what they're finding. So I want to just give you a little visualization of what it is here. Okay, so you see this function, looks like a line, but let's zoom it out a little bit. See, it's got this, as I zoom in a little bit, it's got this action like a cube. It goes up, down, right there. Now the question they're saying is that x equals 3. So I want to make sure I'm at the right. Yeah, so 3 is right here in the middle of these grids. So right here at this point, okay, right there. At 3, negative 45, the point we found. So right here, realize what's going on at this point. So I'm going to highlight this a little bit. All right, so two things that you're going to be talking about here. Here's this point right here. There it is, okay. So remember, there's a tangent line. It's a bad graph, but let's do it again. There's a line that basically touches your graph. Okay, third time. Let me see if I can get this. So remember, it's going up here, and it's touching your line at one spot right there. Okay, I'm going to draw an extra large one. Okay, so our tangent line touches it right there. What we know is it has a point in common right there. So we found the derivative earlier, and we plugged in the 3. Then we plugged in the 3 to the original. So remember what happens is this tells you the slope of that line. This tells you the y value of the point right there. Okay, so that's what we're finding. That's what's going on here. And in the end, all they're asking for, and I'm going to pull decimals down and show you, we don't need the original picture anymore because the only question they want is, they want to know what is the equation of this line, this black line right here. Now pretend that's a straight line. In order to do that, we need two things. We need to know the slope. Well, guess what? We had it over here. It was 12, somewhere up here. Okay, it's 12. And then we needed a point. Well, guess what? We had this point right here, the point it shares in common with the function. How we got that, we plugged in the 3 to the original function, got that negative 45, and that's how we were able to get the slope, the equation of the line. So that's what's going on here when you're finding these things, what they're asking you to solve and calculate. Okay? So now, let's look at another rule. So I'm going to summarize up here in the vernacular that your book's going to use. Okay, so for the product rule, remember, if you have a function that looks like this, you have a first function times, there's your product, a second function. The derivative of it is the first times the derivative of the second plus the second times the derivative of the first. That's your shortcut to the derivative. You'll get it in one step. Now, the next one is called the Quotient Rule. Okay, so just like before, how you had a product of two functions, we're going to get a division of two functions, which they call top and bottom. Okay? So if I want to find the derivative of this, the rule is we're going to take the top and the bottom, and we have to go and clean it up a little bit here. Or we don't have to clean it up, but we can jump right into it just like before. Okay? So the quotient rule, and I believe your book's going to use the same notation. I just want to make sure they're using a T and a B. Yeah, okay. So what it is, this is a little bit more. This is one you have to sit down and memorize because it's important also to get the order. You take the bottom function times the derivative of the top. Very similar to the product rule. And then you take the top function times it by the derivative of the bottom. But here's the key. There's a subtraction right there. And you cannot reverse these. You can't take the top times the derivative of the bottom minus the bottom times derivative of the top. It has to be in this order. It has to be bottom, derivative, top, then subtraction. And then the other part that's new, because it's a fraction, you take the original bottom function as it is, no derivative, and you square it. Basically multiply it by itself. Okay? So, let me give you an example here, show you what's going on. Let's say we have f of x equals to x squared over 2x minus 1. Now, right now as it is, there's no way to solve this without the quotient rule. You can't simplify it, you can't get this down to one term, mainly because there's more than one term down here. If this is one term on the bottom, I can split this into multiple fractions. If it was the other way, if the x squared was on the bottom and the 2x minus 1 is on top, I can go break it down and get each individual piece. But when you have two or more terms on the bottom, there is no simplification. There's nothing you can do to clean this up. So because of that, you have no choice but to do the product rule. The quotient rule. Whereas with the product rule, you could expand it out, you can get the answer, and you'll still get it. But the quotient rule, this is the only way to do it. So I'll break it down carefully. Now, I like to do this one immediately. You just take the bottom, put it in a parenthesis, and square it. Okay, a lot of people work from top to bottom. I like to do that on the bottom because so many times I see it where people spend so much effort on the top, because you'll see it's kind of complicated. They just neglect the bottom, and then they just give me this. Oops, I erased everything. Try that again. They will give me just the top right there, and they'll forget all about the bottom. So that's why I like to put that there, just so I don't forget it. But remember the rule. We now take the bottom times the derivative of the top. Now, it doesn't matter if you use parentheses or brackets. I just accidentally did that. Derivative of the top is a 2x. Now, minus the top function times the derivative of the bottom, we get 2. And now I'll clean it up a little bit in this case just to see what we get. Distribute the top, we get a 4x squared minus 2x squared. And I'll tell you, don't multiply out the bottom. All we're going to do is try to simplify it to see if maybe something will cancel, but leave the bottom factored. Leave it in a 2x minus 1 squared form. And on the top, it looks like we get a 2x squared minus 2. Okay, and keep factoring is the key here. Combine and factor. I can pull out a 2. I get an x squared minus 1. And on the top, that does become x plus 1, x minus 1. Nothing cancels, though. Remember, in order for something to cancel in a fraction, it has to be an exact parenthesis canceling with another one. It can't be close. Like 2x squared minus 2 is not 2x squared, 2x minus 1 on the bottom. X minus 1 is not 2x minus 1. So this is our answer. This is our derivative, but that's how we do it doing the quotient rule. That's where it goes. Okay, so got to look at that one. Let me do a word problem here just to kind of give an example. Then I'm going to go right in the homework. So I like to do this section just by example mostly because that's where everyone seems to understand this a little bit more. So total sales S of a video game T months after the game is introduced are given by this formula. S of T equals 125T squared all over T squared plus 100. So they want us to find the derivative, S prime of T. So remember how that works. We have a quotient. So let's break this down. Think of it as top and bottom functions. So look at this one carefully. Make sure I'll walk you through it, but I want to make sure everyone sees it first. So remember, the formula says you square the bottom. Got that. Then it says take the bottom times the derivative of the top. Okay. Minus the top times the derivative of the bottom. And you see what they did? They didn't actually take the derivative yet. They have that little prime right here and that prime right here. They're going to do it in the next step. Okay, and this is perfectly fine if you want to do that. It's still following the formula. And this is, again, why I don't always go by the PowerPoint because I don't like this step. But if it helps you, don't take it out. Keep using it. Okay, this is where I would have been right here. So again, this is the derivative of the top. 125t squared is 250t, the derivative. This one is the derivative of the bottom, which is a 2t. And then now, multiply everything out. Now, so what happens is, some of you might say, well, this looks factored right here. It is, but this part's not included. So if you're trying to simplify something, you want to multiply everything out, combine your like terms, and then once it's all one big expression, then you can try to clean up the top. Notice we didn't mess with the bottom. I didn't FOIL that out. I'm leaving it right as it is. So, I'm sorry. When I FOIL this on the top, I end up getting this 250t cubed minus 25,000t minus 250t cubed. Combine your similar terms. Well, those cubes cancel out. We just get a 2,500t, 25,000t all over all that. And that's our answer right there. Okay, that's our answer for our derivative. Okay, look that over. Pause if you have to, and then move on. All right, so it looks like it's this, same function. Now they want us to find S of 10 and S prime of 10. And then interpret the results. So, first off, we already found the derivative, and remember the distinction. This one on the left is the original function, this is the derivative. So, to find S of 10, we're going to the original function right up here. We're replacing every t with a 10. We get 12,500 over 200. That comes out to 62.5. And remember, when you plug a value into the original formula, you're getting the y coordinate. You're getting the y value. You're getting the coordinate. This means when t is 10, which is 10 months later, it will have a total sales of 62,500. Remember, that's S is in thousands of games. That's what S is right here. Now, after 10 months, like I just said, now we plug that into the derivative. Whole different equation. This is the derivative that we just found on the previous page. This comes out to be 6.25. Remember what the derivative means? That's the rate of change of the sales. So S is sales, S prime is how fast the speed of the sales either increasing or decreasing. If it's a positive number, they're increasing. If it's a negative, they're decreasing. So this means it's increasing at a rate of, remember, they're in the thousands, so it's 6,250 games per single month. That's what's going on here. Okay? And the last one, use the results from B of this example to estimate the total sales after 11 months. Remember we did this before. You find the value of 10, and then you use the derivative. Whatever you get for the derivative, you add or subtract that to the previous value, and that will be the estimate for 1 month later. Okay, that was something we did about a week or two ago. So if they're asking what's the projected for 11 months, you go find the 10 months, find the derivative at 10 months, add the values or subtract them together, and that'll give you the prediction of what they expect it to be on the 11th month. Okay, so let's get to some homework here. We're in the second half of homework number 7 here. So remember we had a number of questions left. Let's just go right to 35 and you'll see how these things look. Okay? All right, here is number 35. So they want us to find the derivative of tx over bx without using the quotient rule. And then b prime over b prime, note that the answer b is different from, okay. So they wanted to kind of show you the difference of the mistakes somebody will make. So they want to take these two and divide them. So t of x over b of x, based on what they gave us here, that's x to the 7th over x to the 3rd. Now we know that simplifies into x to the 4th from the old rule of powers. Now we find the derivative of that, and that's simply a 4x cubed. Okay, so that's the derivative of that function. We didn't use the quotient rule. They wanted you just to use it, the regular way. Okay, simplifying. Now they wanted you to see what happens when you get t prime of x over b prime of x. So think about it. If you look right here, that's t, so t prime is 7x to the 6th. Here's b, the derivative of that is 3x squared. So when I simplify this thing, it looks like we get an x to the 4th, and I get a 7/3 x to the 4th. And the lesson they're trying to get us to see is this is completely different than what you get our first problem here, where we got 4x to the 3rd. Okay, so we got the answers right. What they're trying to get you to see is that you can't just take the two derivatives right here on b and then divide the answers. It doesn't work that way. That's not the rule. The rule is with the quotient rule, where you have this minus this times, they multiply them and subtract them, then you put it over the bottom squared. That's the way to do it. You cannot just take each individual derivative. All right, got to do some extra steps there. Okay, so let's look at number 39 now. I'm just kind of scanning these to make sure we're not missing anything that is going to be a little too much or out of your, that you didn't know how to do, but I think we're good on all of these so far. Now we'll look at number 39. And they say, find the derivative, and they want you to simplify it. So get the derivative and then clean it up as best you can. And like I keep saying, it's all algebra. So once you master the quotient rule, then you're going to be able to do it fine, but you have to make sure you can use your algebra to clean this up. Okay, so remember, going by the quotient rule here, we take the bottom and we square it. That's the quotient rule. Okay, then we take on the top, on the result here, the answer of this, remember the rule. You take the bottom as it is times the derivative of the top minus the top times the derivative of the bottom. Well, the derivative of the bottom, x minus 21, is just plain 1. So that's all we have there. Now this is the derivative, but you have to clean it up a little bit. So remember, the same steps are going to be there almost every problem. Don't mess with this bottom piece that's being squared. Just leave it there for now. But on the top, let's simplify everything. And it looks like we get a negative 21 over x minus 21 squared. So the x's happen to cancel out. Sometimes they will, sometimes they won't. Don't assume they always will. And now I look at which one I have. Okay, they didn't tell us, they did say simplify, but it looks like they didn't. So I'm thinking it's two parts. Yeah, the first part is just finding this, what we had on top. And it looks like the one that matches what we had is this first one. But like I always do, I'm going to check them all. This one has them the backwards order. Almost right, but no, and they mess up on the denominator. Don't take the derivative of the denominator. You leave that intact. Then over here on this one, this is good on the top, but they mess up the denominator. This one is bad on the top and a good denominator, so A is our answer for this. Okay, now part B is they want us to simplify it into the answer that I have over there. So minus 21 over x minus 21 squared. And people will ask me, well, do I put the negative in front or does it be with the 21? And it doesn't matter. When you have a negative fraction, it can be the top, it could be the middle, or it could even be in front of this bottom parenthesis, as long as you don't have it both top and bottom. As long as you have exactly one of those in front, you have the answer. So there's our answer there. And again, pause if you need to spend a little more time looking at this. If not, we'll move on to number 43. And kind of like the last homework, you're going to see that a lot of these are not so bad. They're small, quick hitting problems. They're not exactly, super long in working them out. So that's why I want to make sure, we get through as many as we can. There's a lot of them, but they're a little bit quicker. They don't take as much here. Okay, so number 43, they're asking us to differentiate this one. So now look at what we have. And here's the trick. The moment I see, if you have a number multiplying to an x, you don't need to do the product rule because it's just a coefficient. Those just come down to the bottom. When you have two things multiplied together that both have x's, this is when the product rule comes into play. And this is a great example of a problem where there is no other way to do this problem. It has to be with a product rule just because there is no simplifying that I can do. This is kind of already simplified. So remember the formula. We take the first times the derivative of the second. Well, that's just e to the x. So first times the derivative of the second. If that's the first, that's the second. Plus, because it's product rule, the second times the derivative of the first, well, that's an 11x to the 10th. And that is our derivative right there, okay? Now, I'm assuming they're going to want us to clean this up a little bit, so I want to show you how this thing works out. And I'm going to try to plug in a couple of different answers as well, just to see what we have here. Okay, so these are the two terms we have, and the cleanup I mean is, well, I can take and I can factor out an ex, because they both have an ex. And I can factor out an x to the 10th because they all have at least 10 x's. So when you factor something out, remember it's like you're dividing it. So if I factor out 10 x's, I'm left with 1 with the first thing. If I factor out 10 x's with the second, those all go away and all I have is the 11. And that right there is my simplified answer. Okay, so now like I said, if I left it as the original right here, let's just say, I'm going to play around with this to learn the system. Let's just say I left it here and tried to enter this answer. So I did this, It may take it because it's technically correct, and it didn't say simplify, but I want you guys to get in the habit of simplifying. And yeah, see, it took it right there. So I could have entered that first one. I could have entered this last one. I could have entered the middle one. They would have taken them all. And that's the key of reading the directions. If it says simplify, you got to take it down to what I have in this box. And I still would tell you I'd recommend try to get down to this line because this is the one you're going to use. And it's always to your advantage to have the more simplified one. But if you left it in this raw form right here, you would have gotten credit on this one. If it doesn't say simplify. So make sure you're seeing that or not seeing that. Okay, so let's look at number 47. Doing the same kind of stuff here. Okay, so 47, they want us to use go back there. Find f prime of x and simplify. So this is one of these where they want us to go do the derivative, and then they want you to simplify it. It looks like it's a two-part. Yeah, I see the part 1 of 2 we're on right now. So that's sort of your go-ahead of you don't have to write out every single step, or you don't have to clean it up all the way, just get the derivative first. And I like this on your homework because it lets you sort of make sure you're doing the first part right before you waste all this time simplifying and trying to clean up the second. So all you have to do is just use this to find the derivative. That's it. Okay, so we're going to do the product rule again. So we have 0.5x plus 3, 0.8x minus 2. So once again, it's the first times the derivative of the second, which is just a 0.8. Then you, you add the second times the derivative of the first, which is the 0.5. Okay, now like I said, that's the derivative. That's all you have to do. So let's look and see what we have here. We're looking for the one that matches. Definitely not the first one. It's not the first derivative and the second derivative, and that's it. It's not that one. Here, we have all the same ones. There's some minor differences. We have a 0.5x plus 3 times 0.8. It's one of these middle two. This one is by 0.5, so not that one. And this is a minus, this is a plus. This looks like it matches everything we have. Check it, and we're good on that one. Now, part 2 is the cleaning up. So you take this answer that we just had, and now you're just going to distribute everything out and just see what you end up with. So we get a 0.4x plus 2.4. And notice, that's me distributing this. And then I'm going to do the same thing over here. We get a 0.4x, again, minus a 1. Now I'm doing this math really quick in my head. I want to make sure I didn't do anything wrong. And that looks like it's as simple as I can make it. I can't simplify it anymore, and I think that's right. Oh, we'll find out in a second. F prime of x equals, another thing I noticed too, some students accidentally will do this. They'll put the f prime of x equals, and they'll put it in there, and they'll mark it wrong because it already has the f prime of x there. They just want the result. So just give the 0.8x plus 3.4. Excuse me. Okay, and instead I got to check my math a little better here. So we know this part was right. All right, 0.5 times 0.8 should be a 0.4x. This should be a 2.4. Oh, I see my mistake right here. Positive 2.4 minus 1. This is supposed to be a 1.4. That's why we do it on the homework, not on the quiz. This is where you're going to make your mistakes and you learn from those. Okay, so let's look at number 51. Okay, now we have another one. This one, they want an exact answer. And again, it didn't say simplify, but let's kind of experiment with this. And I like to test the system out. You all can see what's going on to try to get some of these mistakes out in the open now so that you don't get frustrated when you're trying to do your homework and you think you've done everything right, but it's not liking your answers. So, doing my product rule. Take the first times the derivative of the second. Add the second times the derivative of the first. And notice, I always use parentheses. I like to, that way you don't make the mistake, and very crucial, parenthesis times parenthesis, parenthesis times parenthesis, but not all of them multiply together. You have to make sure that plus is there. Okay, now, I'm going to pretend like I don't know what's going on and say, well, let me just enter this answer here. My guess is it's going to work because it worked last time, but not 100% sure. That's why I'm doing this here. Excuse me. Okay, so I plug it in, and they took it. It was fine. Okay, but even though they didn't ask for it further, my recommendation is I want you to simplify this a little bit more. Okay, so I can factor, sometimes this happens, I can factor a 2x out of both of these. And that will leave me the x squared minus 7 plus the x squared plus 8. And that becomes 2x squared plus 1. And that's my best, cleanest answer, or put a parenthesis there, of course. Okay? And that would have worked just the same if you plugged it in there. But as we're seeing here, if it doesn't tell you to simplify, they're going to be fine with the answer. Okay? So pause that if you need to look at it more. And we'll jump on to 55 now. Okay, so now we're going to find the derivative of this. And notice it's going to start stacking on the things you learn. Like, remember, we just learned about this natural log of x. So to find this derivative, we're going to do our quotient rule. The quotient rule first says take the bottom, put a parenthesis around it, and you square it. Then it says you take the bottom times the derivative of the top. Remember what the derivative of natural log of x is? It's that 1 over x. That hasn't been that long. I know you know it. And then times the derivative of a top times the derivative of the bottom, which is just a plain 1. So now, clean this up. Now, again, they didn't tell us to do any kind of simplifying. You could, I believe, if you enter that one, you're going to be good to go. So I'm going to be a little more difficult and say, let's just go ahead and distribute this. So 14 times 1 over x is 14 over x. X times 1 over x, remember, it doesn't cancel off and become a 0. That becomes x over x, which is a 1. Don't drop the 1. Okay, so I'm going to simplify it a little bit. We could technically simplify some more, but I'm going to leave it right there just to test out the system, and I want to see how they like this answer. So it's like a half simplification here. So I'm going to use this fraction tool. I have a 14 over x plus 1 plus natural log of x all over 14 plus x squared. And what do they not like about that one? Okay. And remember, they're always going to give you a hint. I'm guessing they didn't like my format here. Let's go look at the work one more time. Bottom is squared. Good. Bottom times derivative of the top plus the top times the derivative of the bottom. 14 over x plus 1 plus natural log of x. Okay. So it's right, but I'm going to pretend like, okay, well, maybe they didn't like me simplifying this all the way, so let me just do this. Okay. All right, they're not liking any of these here. Well, we got the derivative. We have the answer right. Really, I'm not sure why it's being finicky on this one right here. Don't want to check it yet. All right, that's the only one I can guess, but what do they tell me? Yeah. Okay. Yeah. What it was, and you're going to run into the same frustration. if you can tell, what they did was they took the answer that I had, in this very bottom, and this is the step where I was saying I didn't want to go all the way, but here's what I'm going to do. I'm going to show you why this is their answer. And like I said, this is written by people. Not always are they going to have every contingency accounted for, and it's not always clear. So I apologize if you get this same frustration. What's going to happen is, on this top, I'm going to factor out an x on the bottom. Okay, now how I'm going to do that first is I'm going to make a common denominator of everything right there. So you see how I just added, put an x right there. I made them all have a denominator of x. Okay, every one of those. Okay, trying to clear out some space here. Okay, so now I can factor out this x. Let's move it up here. And all these steps, they're not necessary. I'm just trying to show you exactly every step, how they got to where they got to. And like I said, I apologize because sometimes they say simplify. They meant simplify on this one, they just didn't say it. And so I'm trying to get you all to see what's a better way to know this without having to go through the same hassle that I'm going through right now. So you see what happens is I just take this 1 over x and it becomes an x on the bottom. And this is the answer. It's the same exact answer that we had, but now it's in the form that they wanted. And the only thing I see here is, oh, okay, now I'm going to put my foot in my mouth. I do see one mistake. See if any of you caught that. Major mistake. Right there. That's why they marked it wrong. It wasn't so much the form. It was because the quotient rule says that's supposed to be negative. So that should have been a negative, that should have been a negative, that should have been a negative, and that should have been a negative. Okay, so I'm going to wager it was good. Our first answer would have been fine. It's just that we had made one little error right there. So messed it up there. So maybe it's not going to be as unclear as I was assuming. So just for fun, let me do a similar example here. And I'll do this one a little bit faster since we've already done it. I don't want to make you guys sit through this again. But just so that we can have some peace of mind that we did this right. And I'm hoping you've all noticed that if you get a question wrong, yes, just hit that similar exercises like we always do. And that gives you a chance to get a higher score on the homework here. So, that's squared. We take the bottom times the derivative of the top minus the top times the derivative of the bottom. Okay, so I'm just going to plug in this first version, see how it looks. We have 49 plus 49 plus x times 1 over x minus ln x times 1 all over 49 plus x squared. And just like that. Okay, I was giving it a hard time here. It was all because of my missing negative. So they are going to be a little more flexible on this one. Try that one out. Should be good on this one now. Okay, wasted a couple minutes, but we'll get back on track here. Let's look at number 59. They want us to find h of x where f of x is an unspecified differentiable function. Okay, so what we're doing is we have to find the derivative, but we don't know what that other function is. It's kind of a mystery what that second function is right there. So let me rewrite it a little bit bigger so you can see it. We have h of x equals 3e to the x f of x. Okay, so when you're drawing it out, that 3, so a lot of people will say, well, okay, we got this, and we have this as my first and second function. But it's more to that. You got to include that 3 somewhere, so I'm just going to incorporate that 3 into this whole first thing. Okay? That way I've got the entire function. These are the 2 things that are being multiplied together, hence our product rule. So when I do the product rule, even though I can't get an answer for that second one, let's just follow the rules. Sorry, no division this time, not the quotient rule. We take the first, 3e to the x, times the derivative of the second. Well, I don't know it. I'm just going to write that f prime of x right here. All right? Then you take the second times the derivative of the first, which is 3e to the x. So there's my derivative. Now, if you look at all these answers over here, they have done a little cleaning up. They've simplified it a little bit because none of these look like our answer. So this is where we're going to take it a step further, why it's good to know how to simplify. And I see that both of my terms, they both have this 3e to the x. So what I'm going to do, I'm going to factor out that 3e to the x, and I'm going to be left with an f prime of x and an f of x there. And because I'm using parentheses, let's use a bracket, and that's what they appear to be using as well. Okay, so now I look at my choices here. This one looks like it is it. This one's close, except they needed to have something around it like that. So that looks like our answer there, that second one. And the other 2, looks like the first and third choice, looks like they decided to just forget that there was a 3 there. And that happens sometimes. You can't forget that. Okay, and that's all they're doing on this one. So it's actually easier because you don't have to do much work. It's more difficult because you feel like it's uncompleted, incomplete here. I couldn't get a final resolution. That's it. That's all you have to do on this problem. That's all that was being asked on number 59. Okay, let's look at number 63. Okay, on this one, find dy dt, which is, again, just another way to write the derivative of the function y equals, parenthesis, 2.3t minus 4t squared times 3t plus 1 2/10. All right, so again, I'm going to lay these out, and it won't hurt you to do this. Let's call this the first. Let's call this the second. And even if you need to, you can write out the formula right above it, especially when you're first learning it here. Remember, it's first times the derivative of the second plus second times derivative of the first. That's what I'm going to do right below here. Okay, and everyone, if you're wondering why is it dy dt, remember, the letter in front of this function is a y, so it's dy, the derivative of that, and the bottom letter is what you have on the other side, which is a t. It's with respect to the t. We're taking the derivative with t being our focal variable on the other side. That's why it's a dy dt right here. Okay, so we take the first, which is the 2.3t minus 4t squared, times the derivative of the second, which is just a plain 3. And notice I can just do this in our head. That's the goal. Do the derivatives in our head because they're not that complicated. So this one is the second, unchanged, times the derivative of the first, which is 2.3 minus 8t. Okay? Now, do they want us to simplify or not? I don't see anything right here, so it looks like we're going to be good with our answer as is. I still want you to get used to it, so I'm gonna type this in just to see if it works, and if it doesn't work, either way, I'm going to simplify this some more. Okay, and got it. So it counted. It didn't need to be any more simplified, but if you were to simplify, I want you to get used to this because this is what's going to be happening. I'm distributing this 3 here and here. I'm going to FOIL out all of this stuff over here on the right. Okay, don't forget how to FOIL, and if you need to use your calculator, use it here. So I do that, That looks like I get a 6.9t. When I do that, I get a negative 24t squared. I do that. I'm going to use my calculator because I don't want to try to do this in my head and get it wrong. So I'm multiplying the 1.2 times the 2.3. Oh, there it is. Sorry. Had it off screen. Okay, 1.2 times 2.3. 2.76. And then last, we multiply 1.2 times negative 8t. That looks like that's going to be a negative 9.6t. Okay, so we just need to clean everything up. We want to write it always in descending order. So to start with this one, we have a negative 36t squared. Then all the t's, we get a 6.9, another 6.9, and a negative 9.6. Use your calculator. Don't feel you need to try to do this and show off in your head here. Get it right. 13.8 minus the 9.6, that's a 4.2t. And last, my number, I think I only had that one number, that 276. So this right here, that's the simplified version. It's the same answer as this one right here, but it's the better form. Okay? Even though they're not asking for it in the homework, I'm going to keep telling you, try to get in the habit of doing that. Maybe if you're running late on the homework, you can't do them all, then don't feel like you obligated to do them all, but once in a while, try to do them. And if you have time, try to do them for all. I'm just telling you because it's the practice you need in algebra. It's all algebra from here. The derivative, you're going to see this is an easy step. It's the cleanup that takes a lot of work. That's the hassle here. Okay, so let's get back to the business here. Let's look at number 67. Okay, well, that's coming up a little bit here. Find the derivative of this function right here. Okay, so we have y equals 41 plus e to the t natural log t. Now what's going to happen is these get more complicated. You have to identify the two things that are multiplying together. Call them first and second if you want. Okay? So now we have them. There's the first, it's not an e, 41 plus e to the t. So first times the derivative of the second. That's supposed to be a 1 over t. Plus the second times derivative of the first, which is just an et. Okay, now like I said, I can clean this up some more because you have a lot of homework problems, we probably don't need to do that. I think the intent of this chapter, because we're going to have plenty of time for this, but the intent is just getting you to try to master the techniques. Plus ln(t). I'll even pretend I'm using parentheses on everything because that's a good habit. That should be good, and here it is. Okay, that's number 67. Let's look at number 71. Okay, so now we want to find f prime of x and the values where x of x where the function is equal to 0. So this is where we start getting into the core of what's going to be happening, what you're going to be using the derivative for. So it's a little precursor of what you're going to see a lot of in the next couple of weeks. So the common approach is always going to be go find the derivative and then find out what x values make your derivative equal to 0. But first step, let's find the derivative. So once again, you're going to get used to doing this because you can do it so often. First times derivative of the second plus second times derivative of the first. Now this is one where I am going to clean it up a little bit. Let's say I didn't, but yeah, here's what we're going to do. What we're supposed to do is We want to know what's the value of x, and they tell you the derivative is 0, so I'm going to put a big 0 right here. So in order to solve this, I need to clean this up a little bit more. I need to know what I'm dealing with. Now you'll start to see this looks a little familiar. We have a 6x squared minus a 44x. Got all those. And now when you have something equal to 0, remember the rule. You combine them all, have them in descending order, and factor everything out. So I can factor out a 2, not a 3. And I can factor out an x, so that's going to leave me with a 3x minus 22. Hope I did that right. And then remember the rule. When you have something factored equal to 0, you set each piece equal to 0, and then you solve. So let's go over here on the left. 0 equals 2x, or 0 equals 3x minus 22. Well, that one gives me an x of 0. This one gives me a 22 plus 3x, so I get 22 over 3. Let me make that a little neater. So those are the two x values, that one and that one right there. Okay, so we have a 0 and we have a 22 over 3. Hope I did that a bit a little quick here, but let's see what we did wrong here. Okay, pause it and see if you can figure out what it was. I get in the habit of just slowing this down. Okay, so see if you get it. It's me not able to read my own writing. I'm going to make a modification here on the fly. It's supposed to be x squared plus 54. See that? Somehow, I made this a 5x. That was just pretty stupid. So, I'm going to clean up everything here. That messes up everything. This is not a 10x. This is going to be a 108. This is still going to be a 6x squared. Now, we get a minus 54x plus 108, and we have to factor out a little bit. So first off, I factor out a 6. And then I want to factor this. It's still all about factoring. X minus 6, x minus 3 should work. And at least that makes our stuff here on the right side a little bit nicer. So we set each of those factors equal to 0. Well, when it's a constant, you don't have to worry about the constant. But you set each of the other factors equal to 0 there. So we get x equals 6, x equals 3. Completely different answers, and you see one tiny typo gave me completely different answers. Let's hope I caught the only error. I didn't. I'm catching another one here. Let's see if I can figure this one out. Yeah, okay. I might just do the whole problem again. I see my other second. Let's see. Okay. Okay, I think our answer is good. No, there is an error here. What I'm realizing, the thing I tell you all to watch out for, they didn't ask for the solution here first. I'm jumping the gun a little bit here. First, find the derivative. I got to look at it. There's two parts here. First, my derivative is all of this. Now, it didn't say simplify, so we could have used that one. All of these are the derivatives, by the way. Okay, that's f prime of x. That's still f prime of x. That's f prime of x. So all these are the derivatives. They should work. I'll just go with that last one. I'll go the one right before. 6x squared minus 54x plus 108. Okay, yeah, they just wanted the derivative. Now we have to plug this in here, and we get the answers of 3 and 6. I think those are good. Yep, there they go. Okay, so we had it. I was jumping the gun a little bit, one each step in that case. So again, pause if you need to look this over now that we have it right, and we'll resume. Let's look at number 75. Okay, So they want you to find the derivative in two ways. One, using the quotient rule, and two, simplifying first. Okay, so look at the two choices. Now you see how they have all these different options here. Which of the following is using the quotient rule? Got 6 choices here, so we have to make sure we're getting this correct. Okay, so remember how it works. The quotient rule. You take the bottom and you square it. Then you take the bottom times the derivative of the top, which is 9x to the 8th, minus the top, and that's x to the 9th, times the derivative of the bottom. Okay? Now all these choices, look at the ones you have here. Now I'm going to start with the easy one. This bottom is x to the 18th, 9 times 2. They don't have any of that, but you know it's x to the 9th to the 2nd. So this one is out, this one is out, this one is out. So we're down to 3 choices just from the denominator alone. Okay, now we start looking at the numerator part. We get an x9 times 9x to the 8th. Oh, and they didn't do that either. They just left it one step earlier. Okay, again, I don't like how this is going for the way they use the notation. But remember, they'd say, go back to my quotient rule here. We take the bottom times the derivative of the top. They put that little hash right there. So we already got the 9x to the 8th. This is just the step before. Just like this one is going to be the derivative of the bottom, which is that, like that. So the next step would have been what I just had. So I basically skipped one step on them, and they actually wanted it right before. So that's okay. We can still adjust to that. So this is what I had a second ago. Okay, so now we look at what's out there. There's an x9th and a derivative of that expression. That looks good. That does not look good. That looks good. Now the second half, it should be a minus. That's a plus. This one is out already. That one has the minus. Now let's just make sure the last part's good. X to the 9th plus 7, derivative x9. So yeah, it looks like B is our choice after all that. Now again, when I do these examples, I like to make sure I go over every one of them. I would suggest that for all of you just the same, okay? Just to make sure you're not missing something, because a lot of these, they look good, and it's not until you're starting to check the answer that you realize, oh, that one was off by a very minuscule amount, and I would have noticed it if I had checked them all. So now they want you to simplify this completely. So remember, I talked about this before, when you have one term on the denominator, you can actually rewrite this. So I can take that same function, notice not a derivative, I could take that function and write them both over the x to the 9. So that becomes a 1 and a 7 over x to the 9. That's the simplified version of the original function. Okay, now, if we're going to take the derivative of that, it would be good to go ahead and move that to an x to the negative 9th. I don't believe we're going to need to put that here when we enter our answer. Yep, and we get that fine. Okay? And then your third part, using either method, get the derivative. And this is a case where I'm going to tell you, this is probably your easier way. Notice it's still the original equation, f of x. Now I've got it ready to do the derivative, negative 63x to the 10th, negative 10, or negative 63 over x to the 10th. That sometimes the other way of simplifying and then doing the derivative is the better way. The quotient rule would have given us the same answer, but sometimes it takes a little bit longer. You know, we were on our way on that one I had earlier. This will get us to the answer a little bit faster. Okay, but either way, if you would have taken the quotient rule and then cleaned it up, it may not have cleaned up to be exactly this, but it probably would have been something close, and even a non-simplified answer probably would have worked. Okay, let's look at number 79. All right, now they just want us to find the derivative. So we have two options. We can take the and FOIL this thing out, or we can do the product rule as it is. So just to fit in with the idea of us learning the product rule, I'm going to do it that way. Okay, just to get you in this habit. First times derivative of the second plus second times derivative of the first, which is just a 1. That's my derivative. And now I'm going to FOIL this out just to clean it up. And I'm assuming, again, if you were to plug that answer in right now, you'd get the correct answer. But I'm going to take it a step further just while we're here online. We can show every step. I'm going to FOIL this out. I'm going to distribute this one, which really is just distributing by 1, so nothing happens over here. And then simplify our terms. We have 4x to the third. We have a 3x squared. We have a 16x, and it looks like we have a 10. Okay, I ran that one kind of quick. I'm just going to check over my work real quick before I plug it in. Everything in the first line looks good, so if I would have used that, I would have been home free. FOIL it out, 3x cubed plus 8x plus a 3x squared plus an 8. That looks good. The other part looks good. Simplify our terms. I think everything's going to work out. Well, we'll see in a second here. So we get a 4x to the third plus 3x squared plus 16x plus 10. And that is it for that. Okay, so again, pause and see if you need to look this over anymore. I think that was the last, yeah, that was the last one of these every thirds. Let's get out of here. And like I said, these, it's good and bad the way the homework is. Some parts I don't like how they do their multiple choices, but I do like the fact that they're sort of encouraging you to do each of the steps and getting you used to doing everything. So as you can tell, this homework is going to take a little bit longer. Mainly because there's more problems. Some of them take a few minutes. Some of them are very quick, but make sure you allot the appropriate time to do these because obviously you've got 80 of them to do here, so it's going to take a little bit longer. Like always, if you have any questions, shoot me an email and I'll be happy to help you out. Have a good one.